lesson 2 for our chapter 1. So lesson 2 talks about the two ways of how to define a set. Okay, so before, in lesson 1, we tried to determine if a certain collection can be considered a set or not. And we can consider if a set collection is a set if that collection is well defined, the description is very clear and specific. So let us consider this problem. So list down the members of the set below, collection of all the prime numbers between 10 and 20. So what you're going to do is not to name this into a formal notation in two ways. So we use capital letters in naming a set. Then the members, each members of those of this set shall be enclosed within braces. Okay. So the members of a set. So let us say here collection of all prime numbers between 10 and 20. That's 11, 13, 17, and 19. So these are the members of this set. Okay, so we call them 11, 13, 17, and 19. Called it as an elements of a set. Okay, the symbol for element is this one. The symbol for not element is just this one. Okay. So with this definition in this paragraph, we can name this set in this problem as the set of all A. So A equals to, then we enclose the description in that open and close brace. So prime numbers between 10 and 20. How do we read this formally? We read it formally as A is the set of all prime numbers between 10 and 20. So this way of defining a set is called set builder notation. Okay, set builder notation. Set A can also be written in this way. So we can also write this as A is the set of all X such that X is a prime number, okay, between 10 and 20. So we read it as A is the set of all X such that X is a prime number between 10 and 20. So the symbol, this vertical line here, we call it such that. So another way of defining a set is using a roster method. In this method, we simply list down the elements of a set. So the set in that exploration a while ago, the 11, 13, so we simply list down the elements in that set. So that can be written as like that. So when we just simply describe or give the description of a set, that's what we call the set builder notation. When we list down the elements of a set, that's what we call the roster method. Okay. So these members, the members 11, 13, 17, and 19 are called elements of a set. In symbol, we write 11 is an element of A because 11 belongs to set A. Okay. We write 12 is not an element of A because we cannot find 12 in that set. Okay. So for example, we have here, write the sets below in set builder notation. So remember, when we write a set in a set builder notation, we have to describe, we have to give a description, we have to give a well-defined description of these elements. Okay, so the elements in set B are 1, 2, 3, up to 10. So how do we describe it? How do we put it into words? Okay, in such that our description into words should be well-defined and specific and or clear. So we can actually name this in three ways. Okay, so first is we can say B is the set of all B is the set of the first 10 counting numbers. So of course 1 to 10 are counting numbers, so B is the set of the first 10 counting numbers. We can also, aside from saying that it's counting numbers, we can also say that B is the set of all natural numbers from 1 to 10. We say natural numbers, those we use in counting. Okay, those we use in counting. We can also say that this is just B is the set of all X such that X is a positive integer from 1 to 10. So any of this description is acceptable. Letter B, set P, the elements are A, B, C, D, and E. So we describe it as first 5 letters of the English alphabet, or we try to express it in set builder notation as P is the set of all first 5 letters of the English alphabet. So as you can see, it is very emphasized that that these are English alphabet, because we have many alphabets. We have Arabic alphabet, Chinese alphabet, Japanese alphabet. So you need to specify what type of alphabet we are referring to. So this is how we write a set into a set builder notation. So let's have here the numbers are 2, 4, 6. The elements are 2, 4, 6 until 20. So we can express this set in set builder notation as multiples of 2 less than or equal to 20. So A is the set of all multiples of 2 less than or equal to 20. We can also, aside from saying these are multiples of 2, we can also say A is the set of all even numbers less than or equal to 20. A is the set of all even numbers less than or equal to 20. Number 2, we have B, set B. The elements of set B are Luzon, Visayas, and Mindanao. So these are major islands in the Philippines. So basically, that's how we express a set into a set builder notation. So here, let's try to express the following sets in roster method, which is the opposite of the set builder notation. So again, in roster method, we simply list down the elements of that set. So we have your set T. Set T is the set of all multiples of 5 less than 50. So if you're going to list down this element, we have 5, 10, 15, 20, 30, 25, 30, 35, 40, and we should stop at 45 because the set limits us at less than 50. So for letter B, we have here. So how do we read this? We read this as set of all x. Okay, set M is the set of all x greater than 5 but less than 10. So greater than 5, set of all x greater than 5 but less than 10, where x is a whole number. So it's like it's telling us that all those whole numbers greater than 5 but less than 10. So we have here. So these are the elements are 6, 7, 8, and 9. So basically, that's how we write a set into a roster method using a roster method. So we have here set A is the set of all odd numbers between 50 and 60. So odd numbers, we have 51, 53, 55, 57, 59. Then we have set B, set of all x such that x is a natural number. So again, natural number, those we use in counting, less than 8. That is 1, 2, 3, 4, 5, 6, 7. Okay, so this is roster method. So here we talked a while ago about the concept of elements. So we can say that a certain member is an element of a set if we can find that member in a set. Okay, so let us say here we have 3 is an element. 3 is an element of A. So the question is, can we find 3 in A, saying that A is the set of all even numbers less than 10? So that is false, because 3 is not an even number. 3 is an element of B, so number 2. 3 is an element of B. So what is the set B? Set B is the set of all multiples of 3 less than 30. So basically 3 is a multiple of 3. So this is true. Then number 3, is an element of C. C tells us that set C is the set of all x such that x is an odd number. So 3 is an odd number, so this is true. 8 is an element of A. 8 is an even number, so this is true. Number 5, 18 is an element of B. So B is 18 is not an element of B. But set B tells us that these are multiples of 3 less than 30. 18 is a multiple of 3, so this is false. So that's how that ends our lesson 2. So again, to summarize, there are 2 ways of naming a set or expressing a set. We can express it using the set builder notation, where we try to describe the set in 2 words such that the description should be clear and specific and should be well defined. The other one is by using roster method, in which we try to list down all the elements of a set.